Okay, continuing on with exercise 1A from the textbook, looking at the blue questions now, which are the intermediate questions, going through question 5 to 8. Let's begin. Okay, so all these questions, they are to do with the idea of consequence and equivalence. And let's get into it with question 5. Okay, so it says, where is the flaw in this argument below? So suppose 1 is equal to 3. A bit of an interesting first line there, okay, but it could cause a bit of confusion, right? It says, subtract 2 from both sides. Well, to begin with, okay, that piece of logic is fine. We've got equivalence going both ways because, you know, right, if we just put this arrow in here, there we go. Right, if you subtract 2 from both sides, that means you can go from this line to this line. That is fine. And then going sort of undoing it, if you were to add 2 to both sides, well, minus 1 to 2 gets you back to 1. If you add 2 to 1, you get back to 3. So you have got equivalence. This and this, they work both ways. The logic flows both ways. The issue arises, and this is something you've got to really look out for. If you're squaring something or you're dividing through by 0, you can end up gaining or losing solutions. So right, what they've done here is they've squared both sides. Okay, so minus 1 squared, it is equal to 1, and 1 squared is equal to 1. So to go from here to here, that is okay. The issue is you can't reverse it. So what we'll do is we'll put in the arrows first of all. So we have got consequence, right? We've gone from that second line to the third line, and that is okay. But the issue is, right, if you were to sort of undo this and to root both sides, or if you square root 1, okay, or they're both 1, so if you square root 1 or square root 1, okay, what happens there is if you square root 1, you actually get a second solution, don't you? You get plus or minus 1. So we can't go back from this one by square rooting it to here because you're forgetting or you're missing out this solution, negative 1. So that's where things break down a bit. So for this first line to be true, you've got to have equivalence going both ways throughout the whole thing. We don't. Okay, from the second to third line, it's just consequence. So we cannot read the argument backwards because the last line is not reversible. You can't go back from here to here because if you square root 1, you're forgetting about that solution, negative 1, which is the issue. Okay, so that is the flaw in the argument, and we probably should write it up. So let's do that, and let's do that up here. So where is the flaw in the argument? Something like you cannot read the argument backwards. Can't read the argument backwards because the last line, it is not reversible. Last line is not reversible. Okay, actually, maybe typing it in might be a little bit long-winded in the future, but there we go, right. That is the answer. So the key thing really with these questions is if you're squaring stuff or if you're dividing through by 0, you've got to be really, really careful with consequence and equivalence, which is the case with question 6 here. So consider the equation. We've got the square root of x squared plus 9 is equal to 3x minus 7, okay? And it says add the appropriate symbols, so either equivalence going both ways or consequence in each position marked by an asterisk. So the first one, right, they've squared both sides, okay? So what they've done to get rid of this root sign here is they've squared it to get rid of it, and then they've squared 3x minus 7. If you square 3x minus 7, you do get to this. Okay, and again, you've got to be really careful with squaring because you can gain solutions, basically. Okay, you introduce additional solutions. So right, to get from the first line down to here, that is consequence, not equivalence. We can't reverse it, and I will tell you why in a second. So this line here, this is consequence. It is not equivalence. So to get from here to here, you can square both sides, right, but you can't go back. There's not equivalence. If you were to now square root both sides, so if I was to go and square root this to try and get back to this, well, what's the issue going to be? Okay, so if I was to sort of go back and root both sides, well, the square root of this, okay, would go back to 3x minus 7. Okay, but then if you go and square root this to get back to this, what happens again? If you square root this, we're gaining a plus or minus solution, right? So we're getting, what we're doing, x squared plus 9. X squared plus 9. So you can see, right, the logic, the argument doesn't go both ways. To get from here to here, okay, fine, but we cannot go back from here to here by rooting, because when you root, you introduce another solution. In this case, that is a negative root x squared plus 9, okay? Then the rest of it it looks okay. So we have this here, and they subtract x squared plus 9 from both sides. Basically, right, as long as you're not squaring or square rooting or dividing through by 0, things are going to be okay. That is absolutely fine. So here, we do have equivalence. They mean the same thing. The logic from both of these lines here does go both ways. So this is fine. This is fine. Okay, if we added this back onto this, we'd get back to this, for example. And then here, divide both sides by 2. That is fine. We times everything by 2 again. You'd get back from here to here. Therefore, again, we have equivalence on this line here. So it's not very neat, is it? But it's quite hard to draw these little arrows on here. Okay, that is fine. That is fine. And then finally, factorizing it, this means exactly the same thing as factorized form. So they are equivalent statements. So it's all fine, apart from really that first line. So this goes in here. This goes in here. Okay, there we go. So add appropriate symbols in each position marked by an asterisk in the solution. Am I missing part of the question? I am, yeah. Okay, part B, which I haven't cropped on here, which was my fault. It does say, sorry, hence explain the flaw in the solution given. Sorry, that's not on the question, but we'll go through it anyway. I've got it on my textbook here. Hence explain the flaw in the given solution. So right, we've got x is 5 over 4 and x is equal to 4. What I would just do here is what the flaw is this first line here, okay, which is when squaring, you introduce a additional solution. Let's write this in. So the flaw is that when you square, you introduce an additional solution. Okay, what is that additional solution? Probably the best way just to go and find this is to go and put in these values into the original one and see which one is going to break down. So x is equal to 4 is probably going to be a little bit easier if I put that into this up here. Okay, when x is equal to 4, let's just see if it makes sense. We're going to have the root of x squared, so 4 squared plus 9, and is that equal to 3 times by 4 minus 7? Well, root 16 plus 9 is 5, so this is equal to 5. 3 times 4 is 12, take away 7 is 5. Right, so we can see that 5 is equal to 5. So this solution here, it looks pretty good, okay? And if you were to put 5 over 4, therefore into this one, it would break down. But it would work if you put it into the negative version. And let's just double check that. So, right, if x is equal to 5 over 4, if you put it into, right, the negative root x squared plus 9 part being equal to 3x minus 7, okay, you will see that it does work. If you put this into this, okay, you substitute it in, you would get the same thing on both sides. I'm not going to go through it because you can go through it if you want to, but the question didn't have that negative question initially, so we don't want this solution, right? So we can get rid of this one, right? We don't want this. So there we go, right? The flaw is when you square, which we did here, you get an extra solution, which we didn't want. So we don't need this one. The only solution is x is equal to 4, which satisfies that equation. Okay. Question number 7. Insert the appropriate symbol, again, consequence or equivalent, in each position marked by an asterisk. Okay, just by looking at this one here at a bit of a glance, right, we've got 1 over x squared is equal to 2 over x, and I can see my solutions they give me is x is equal to 0, x is equal to half. You've got to be really careful here, right? If you divide through, if x was equal to 0, you can't divide through by 0. You get an error. It's impossible. You can do 0 divided by something, not the other way around. So straight away, right, just before I even read this, I'm noticing that. So this is not going to be a solution, but that's not going to be enough to answer the question, is it? So we've got to go through this properly. Well, so what have they done here is to get from here to here, they've times by x squared and they've times through by x, so like cross multiplication. Okay, and actually this is where we have the issue. So from this first to second line, it is not equivalence, it is just consequence, and I will explain to you why. So we've just got this going on here. Okay, so we can't go back from this line to this line, and let's try it. Okay, let's try doing that. So over here, we've got x being equal, it's not very well written. We've got x being equal to 2x squared. Let's try and get back to what we've got over here. Okay, so let's try and, I don't know, divide both sides by x to get 2 over x. Well, if I do that, if I divide through here by x and I divide through here by x, well then these will just go. Okay, so I get 1 being equal to 2x. Therefore, x is going to be equal to 1 over 2. Okay, so I get the solution down here, which is good, right? But this solution just doesn't exist. Okay, so yeah, so the first line, right, this line to this line is not reversible. It leads to an incorrect solution, x being equal to 0. So that's explaining the reasoning again. And so I've got to fill in the rest of it. So from here to here, right, then from here to here, they've just taken away the x. That is fine. Look, as long as you're not squaring or dividing through by 0 or something, you're going to be okay. Here, they've just taken away that x. So from the rest of it, it is going to be just equivalence. So that's going to be fine. That's good. That's good. Good. And they factorized it from this line to this line. They mean exactly the same thing. Again, they're not dividing through, sorry, they're not squaring or dividing through by 0. So it's going to be equivalent. So that line also is absolutely good. That is fine. Okay, so that's going to explain the error in the working. So something like this, the first line is not reversible, which we showed. Okay, it leads to an incorrect solution. Okay, you could have also spotted there, right, that if x is 0, it just put it in your calculator, you get an error. It doesn't work out. Okay, good. Question 8, which I believe is the last part. Okay. Right, it says insert an appropriate symbol, again, consequence or equivalent, in each position marked by an asterisk. So this first line, we've got x squared plus 3x is equal to 4x plus 12. Well, to get from this first line to the second line, all they've done is they factorized it, which is fine. Okay, again, you're looking out for squaring or dividing through by 0 or something like that. So this line here and this line, they mean exactly the same thing. You can go both ways. The logic, it flows both ways. So this is good. So I can put the equivalent symbol here. Okay, they mean exactly the same thing. Okay, right, and then this thing here, right, you can see you've got x plus 3 on both sides. You can see what they've done here, right? X is equal to 4. That is one of the solutions to this equation here, right? If x is equal to 4, then this makes sense, okay? That's one solution. But you are missing out on a solution, okay? Which is x being equal to negative 3 also. Okay, so actually, right, the logic doesn't flow both ways. Right, we lose out on a solution minus 3 because, right, we have this, which is fine. We lose a solution. So, right, we've got to go and put it in here that the logic goes from this way to this way. Okay, because we're forgetting about a solution, x being minus 3. Because when x is minus 3, this will be equal to 0, which means this is also equal to 0. Okay, right, so hence explain the error in the working, something like this. So the penultimate line, which means this line here. Okay, so the penultimate line does not imply the final line. Penultimate just means second to last, which results in losing a solution, x being equal to negative 3. Okay, so you've got to be really careful there. Okay, x is 4 is one solution, but you're missing x being equal to minus 3. So that is the error with the working. Okay, and that is it for this video question. What was that? Question 5 to 8. Okay, I actually think these questions are questions that students perhaps find a little bit more awkward. But it's good to really think about them. Okay, you've got to be careful with it. Basically, right, the key thing again is if you're squaring, dividing through by 0, if you're losing solutions, you've got to be thinking about all this kind of stuff. It's really important. Okay, thank you.